And the Los Angeles Times says the sun's magnetic field is about to flip. The effect will be felt throughout the solar system, including Earth.
They say the sun's magnetic fields weaken completely, then re-emerge with opposite polarity. So what does this mean for us on Earth? 2 words: cosmic rays. Some researchers say the rays might affect the cloudiness and climate on Earth.
Okay guys, just to put you out of suspense, you can see what we're going to be talking about. Right, and the reason why we're going to talk about this is because yesterday I went into the backyard with the compass and measured the sun setting at 180 degrees west. So what, you might think, what is the big deal about that? Well, you can check in my archive. I'll include the 2 videos of making the both recordings, all the measurements. But on the 2nd of June 2003, I put up a video talking about the sunset, and I measured it. And when I took a measurement at that point, it was at 310 degrees. Yeah. And we're only in September. The point I'm making is if we was at 310 degrees on the 2nd of June, and it has moved to 180 degrees on the 7th of September, both measurements made this year, that is an indication that the rotational tilt has increased 7 degrees on what it should do already, albeit it should do that. It should reach 23.4 degrees in December, not in September. So if it's moved a total of 30 degrees in 3 months and covered more than its rotational tilt than what it should have done in December, then it's an indication that the Earth's natural wobble has increased, and it's increased by quite an alarming amount. And just to give you an idea, when I done the measurement, it wasn't quite clear. By the way, it was the 2nd of June. We was coming close to the summer solstice, where the sun is at its highest. Now, when I done that measurement, it wasn't 100% clear because of the way I was measuring it, whether that was at 310 degrees or 320 degrees. And I think someone did send me a video was up, but has now been taken down, not by myself, confirming that it was at 320 degrees. Now, I did make a measurement 3 days before the summer solstice, and I thought I'd do it 3 days before because the way the weather was looking that week was looking as though we wasn't going to get clear skies to view the sunset at its position. So, and it turned out, I think it did on the solstice this year, that it was from where we are in the middle of the UK, very poor visibility. So it was probably just as good that I did make that measurement 3 days before. However, because I make a lot of videos, I try and keep my hardware on my hard drive clear. It got deleted and it was never put up on the internet. That's, a real big shame. But thank God I did measure it on the 2nd of June, and that information I've managed to retrieve, and it was showing a 310 degrees sunset, or between 310 and 320 degrees. So if it is 320 degrees on the 2nd of June, then it's a 40 degree axis tilt to this present time. And that means, it has well gone beyond. It's almost doubled its amount that it's supposed to tilt. As far as weather's concerned, well, as you can see on this diagram, if the celestial equator is increased to this position, it's going to put the UK more at an equatorial position, meaning that the sun coming in this way here is going to be, we're going to be receiving more along the lines of the weather that you'd receive closer to the equator because of the way the tilt's gone right over. And therefore, we're going to get more daylight hours in and around about the summer solstice. And when it goes back over on its tilt at the winter time, we're going to get reduction in hours of daylight. And I believe I mentioned this also around last December. I said, did anyone notice in the UK, that it was getting dark around about 4 o'clock? And, you know, if you lived in Australia, did you notice your hours extended of sunlight? Because that is exactly the effects that you get. So the two videos I'm going to put up for you to have a look at show you me making those measurements. Now, it's something you wouldn't notice, guys, gradually happening. So, you know, for the majority of the people, they don't give two hoots about where the sun sets and where it comes up. Only, you know, there are people on this planet that rely on it for navigation, such as the Inuits. You know, they have been complaining that the sun isn't setting in the direction it's supposed to be. We've also had people raising the alarm bells recently about the moon not being setting or coming up in its positions and, you know, acting all quirky. You can find those videos out for yourself, guys, but all I'm saying is if our axis of rotation is tilted more than what it should do, when we look up at the moon, it's not going to look or appear in the place it's supposed to be in any case. So, you know, that can confirm it. The other thing I wanted to make a point of, guys, is that if we have reached 30 degrees tilt and already surpassed the normal rotational axis tilt of 23.4 degrees, and we're only in September, it could be an indication that we have got another 30 degrees before December of tilt to go. So giving us a total of 60 degrees as opposed to 23.4 degrees. And if that is the case, take 23 degrees off of 60 and you almost get the exact position of where the magnetic North Pole is at current. Now, guys, this is the big question. Has the crust slipped over the interior of the Earth? Are we talking crustal displacement? We could quite possibly be talking crustal displacement. And the reason why I say that is because if we've got an increased tilt of nearly the same as what the magnetic pole has migrated over the northern hemisphere, it seems to suggest that the inner core has remained in its fixed position and the crust, the outer crust, has slipped over the inner core. Now, if the inner core is responsible for maintaining the magnetosphere and the magnetic North Pole, and you slide the outer crust over, what it's going to appear like is that the magnetic pole has been migrating. But I think what we're seeing is the crust migrating and the magnetic pole staying where it normally does. And that's probably because of the way we rotate around the sun in our solar system. So, guys, you can see why this is such big news. And you can see probably why, you know, unless you made the measurements, you wouldn't have found this out. Or unless you relied on the sun as a navigation, you would never have noticed the difference. But I'll tell you now, guys, maybe you'll pay more attention to all these people that are screaming and shouting about the sun setting in abnormal positions as to what it usually does. And yes, guys, it will affect the weather. And if we look at stories in biblical terms, and if this tilt gets, or this crustal displacement gets worse, then yes, you know, you can see that, you know, as our winter hours reduce on the northern hemisphere, as the rotation comes back over, we will get less light. And if it talks about 3 days of darkness, well, then you can see why we will get 3 days of darkness, because that will not be facing the sun at that point as it's rotating. I'll leave it with you guys. I'll let you watch the video and, you know, please rate the video and give me your comments on this. And by the way, guys, you know, get someone with a bit of credibility, right, before you start knocking the information in this, right? You'll see the two videos. That's my evidence, right? If you can show me evidence that I'm wrong, then do it in a manner, right, that is credible, right? Don't just come blabbing your mouth out on my channel, right, saying, oh, you know, when we look at the stars, they're in the same place, because I've had just as many amateur astronomers, right, tell me the stars are not in the place of where they're supposed to be. And I've had just as many people tell me that they've seen the sun, setting at a more northerly latitude than normal. So, put your heads back on your necks before you make stupid comments, because I just won't tolerate it.
Ladies and gentlemen, there's been a lot of controversy about the eccentricity of the moon's orbit. This video will prove to you that something is going on within our solar system. We think the conclusions you should draw are rather obvious and almost logical, to the point where to disagree would be a lie. The inclination of the moon's orbit, no matter what reference, no matter what resource, no matter what website, no matter who you talk to, is estimated to be between 5.1 and 5.9 degrees. The inclination of this orbit is not related to the equator because the Earth tilts. It's related to the ecliptic, so of course the position of the moon can change with the seasons. However, having said that, it does not change with respect to the ecliptic. As Venus moves south, entering in towards the summer, and then as Venus heads north, entering into the summer, and back south, entering into the winter, so shall the moon follow Venus. And always, when Venus is in the evening sky, the crescent moon is always closely associated with Venus. It's been that way for centuries, and it's not that way anymore. Now, we can talk about the moon's wobble, and we've already made a video about that. However, more concerning is actually the orbital path of the moon lately. Again, this is to demonstrate how every single solitary reference and resource places the moon's inclination between 5.1 and 5.9 degrees. All the diagrams and all the writing will tell you that there is very little disagreement upon this. And it doesn't matter what university, what government agency, what science book, everybody is pretty much in the agreement that the lunar orbit, the plane of the orbit, does not vary that much. Again, if you look at the middle paragraph, the very first sentence tells you exactly where the moon should be in relation to the ecliptic plane. This is Wikipedia, the next to last sentence. As you can see, there is very, very little disagreement on where the moon should be and has been. Now I'm going to show you some simulations. I'm going to go to Ephemeris and show you where the moon has been and where's the moon appearing in the sky. The first simulation that you're about to see is a little subjective. It calls for a crescent moon on two separate nights. The very first night going to be shown to you is Wednesday. The moon is very, very dim. It's hard to see. But you can see exactly how the visibility of the moon changes quite drastically. now you are looking at a true ephemeris report. This is on the moon. This shows you the extreme vacillations. On July 22nd, we had a full moon. Most of us remember looking for it. It was supposed to be exceptionally large moon. It rose in the southeast sky. Notice the declination is minus 15 degrees. The true coordinates are to the left, so you can verify both the coordinates and the degrees. It wasn't more than a couple weeks later, I was shocked watching it rise up so far north, and the declination was plus 19 degrees. I was shocked to see the moon go from way south to way north. I didn't know what was happening. I did make some comments on some threads. Of course, the debunkers and the people who think they know it all said I was crazy, but now they need to look at this. It went from minus 15 to plus 19 degrees off the ecliptic. I am assuming, well, heck, that's almost 40 degrees, and that's pretty much what I had blogged earlier this month. If you move to August 7th, you can see it was already on its way back down. I mean, look at that difference. It's like 13 degrees in just four days. I found that that's way beyond what its normal annual decline to incline is. I mean, this is just huge deviation in just 4 days. Look at August 14th. That's when I started calling people's attention to what was going on. It was so far south, it almost looked like it was going to set in the south. It was so far south. And on the 18th, which is tonight, you can see it's already started to rise back up towards the ecliptic. This is off of ephemeris. You can see the coordinates next to the degrees of declination. I found it quite astonishing how something can go from minus 15 to plus 19. You can also use these diagrams to show you. A month ago, we all remember these alignments. That was quite fun to see these. This was over a month ago. And you can see that the moon is actually setting north of due west. It's north of Venus. The moon should vacillate no more than 5 degrees north and south of the ecliptic, which Venus is on. A month and a half later, this is just a couple days ago, you can see the moon almost sitting due south. I mean, this is so far south, it's incredible. Venus has moved south as well, but nowhere near like the moon has. And again, we're in an equatorial alignment. Venus is coming around to align with Aquarius as well. If there's a large object, which we think there is in Aquarius, that's influencing these planets, this would explain what we are seeing. We don't think it's proof, we just think it's evidence. And you know, it doesn't take a fool to go to ephemeris. And now all you guys who swear by ephemeris and try to use it to debunk this channel, now you're going to have to tell me that ephemeris isn't accurate or something else. 1 minute it's your godsend, next minute you're going to have to trash it. But here it is, folks. Here's the moon north of west, and here it is way south of west. This is so far south, it's incredible. And it started to incline back towards the ecliptic. Something is going on. We should be calling NASA. We should be calling the Air Force. We should be emailing them and let them know that we know. You should make this video viral. You should post it to as many social medias as you can. This is really something to behold.